Hi, my name is JMeyers, and this is the KI number 5 from CSU. I'm in ECE 332 and ECE 342, and we're going to be talking about all of the components here in this green square of the radio system receiver. We can go through and we can talk about what each one of these do. The antenna is used to transmit and receive signals. The diplexer transfers signals to the transmit circuit. The bandpass filter it allows frequencies within a band width and rejects others. The low noise amplifier is used to amplify low signals received from the antenna. We have our mixer, which is used to add and subtract frequencies from one another, or from the system. Local oscillators are used to amplify low signals, or are used to change the frequency coming from the antenna along with the mixer. The amplifier is used to increase power of the signal, and then the low pass filter allows only low frequency signals, rejects high frequency signals. And in order to manipulate the system and the signal how we please, we can do this in a couple of ways. One of them is to increase the DC gain of the amplifier, and we can do this by increasing the width of the MOSFET here, and by increasing the width, the transconductance increases, which makes the gain increase. It also increases the capacitance. When the capacitance increases, the bandwidth decreases, which promotes DC gain. And additionally, when W increases, ID increases, and this makes our output swing decrease as well. Another way to increase and manipulate the signal is by increasing the bandwidth of the amplifier. And we can do that by increasing the frequency, and through that we need the transconductance of the MOSFET to increase. And if we increase the transconductance, so does the current, and this makes also power dissipation increase. This also makes our R0 of the MOSFET decrease, and from that gain decreases. And the component that we would change in order to increase the bandwidth is to decrease the width, which decreases the capacitances and makes the frequency increase. Next, we are going to look at oscillators, and oscillators convert a DC input into an AC output, and commonly used oscillators are LC oscillators. And they are used because they're good at with phase noise characteristics. They overcome losses of the feedback resonator circuit, which we can see here, the feedback network, and these overcome losses because of capacitors or inductors, as we can see here for these load inductances. Into the resonator circuit. In other words, an oscillator is an amplifier which uses positive feedback that generates an output frequency without the use of an input signal. And then we can look at RF systems. And RF systems are composed of limited circuit blocks like LNA, or low noise amplifiers, mixers, and oscillators. And the max power transfer theorem says that to transfer the maximum amount of power from a source to a load, the load impedance should match the source impedance in the basic circuit. A circuit may be a DC or AC circuit, and its internal resistance or the output impedance drives the load resistance and the load impedance. And then for matching networks, we want maximum power delivered when the speaker impedance matches the output impedance of the amplifier. And that's all I could fit into the window of time, so thank you very much, and I will see you next time.